Hello, this is homework number 3 for EGR 480, and this is a 7-segment display driver. We are going to be displaying a 4-bit number on a 7-segment display. So the first thing you'll notice is that we're using a new standard function as part of the HW3 library. This is the toInteger function as shown here. After we have mapped our ports for the switches and LEDs, we have to map our individual segments of the 7-segment display. And then we have to map our anodes. This allows us to toggle between the 8 different 7-segment displays. If you want multiple showing at the same time, you actually have to cycle through them at a fast speed. Now, as part of our behavioral architecture, all we have is the single signal, which is num, comprised of an integer. Now, anode is an active low, so what this means is that the first segment is displaying. Next, we map our LEDs to these switches. This just allows me to verify that I am activating the right numbers. Now we convert our switch vector to an unsigned vector, and then we convert that to an integer. Now we begin a process on num. It's a switch case statement where we cycle through each of the possible numbers and set it equal to its corresponding 7-segment display. Then all the others we just set off. For this example, we are only going to be able to display 0 through 9. Now, the only other thing that we have a file for is the test bench code, which is very simple. We loop through 16 numbers, and every 100 nanoseconds we go to the next one, each time converting our switches to the logical vector. So as you can see in our simulation, we are going through each switch and the LEDs are lighting up correspondingly. The 7-segment display is hard to decode, but it's all correct. And then the anodes, all of these are always high except for this single one, which is always low because the first position is always what we're going to be using. So now we're going to see it in action on the FPGA. We can go through the numbers. We have a maximum value of 8 though, so if I hit the 4 now, you're going to see that it turns off. But if I just have the 8 and the 1 lit up, then it is equal to 9. So we have every number 0 through 9 accessible from these 4 bits.